It's no secret that one of the reasons many people choose to become developers is because of their love for video games. Video games are fun, engaging, and a great way to kill some free time. Whereas regular programming, for example web development, might have a lot of similarities with game development in that you're still writing code, at the end of the day, there are some aspects of game development that you may not find in other types of programming. Hi, I'm Victor, and today on Heights Above Sea Level, we'll be looking at 8 differences between game programming and regular programming. Starting things off at number 8 is the hardware needed. Regardless of what platform you play on today, the machine will need a graphics card to render textures, 3D models, lighting, environments, animations, and many other things found in the game. If this is what it takes to play the game, then it's probably going to take equally powerful equipment to make the same games, if not better. As a game programmer, you'll be working with textures, environments, animations, and the like to make a game. This comes with a systems requirement that's higher than what you'd need to make, say, a React application. On the other hand, regular programming doesn't require a serious PC to make web applications, desktop apps, or even mobile apps. A half-decent laptop can get the job done. In some cases, even a much older PC or laptop can still be used to make apps worthy of mention. To put this in perspective, Mark Zuckerberg made Facebook back in 2004 when PC hardware was nowhere near where it is now. Today, Facebook is a global company with billions of users, making Mark Zuckerberg, according to Forbes, the 5th richest person in the world with a net worth of about $100 billion. At number 7 is the risk involved. Video games are entertainment products, so if something goes wrong, there isn't really much to lose. Only the super dedicated gamers will lose sleep over their progress in Minecraft being erased. Granted, some of that progress may take hundreds if not thousands of hours to accomplish, but there's still nothing compared to the sensitive information you could lose if your account in a bank application gets compromised. And as much as Facebook is one of the largest companies in the world, it's had its fair share of lawsuits surrounding data being collected without the user's permission. Others like Google, Amazon, and TikTok have also faced similar problems when it comes to privacy and data. For this reason, game programming tends to be a little more forgiving when it comes to such issues with the final product. Take a look at the whole Cyberpunk controversy where everyone was promised one of the most ambitious gaming projects, but what we got at launch instead was a bug-infested mess, especially for consoles. CD Projekt Red had many explanations for how things turned out, but it didn't face as many consequences as it would have had the product been something people use on an everyday basis like a car. Gaming is a very niche activity with a large population not concerned with the logistics that come with releasing a game. Most of them wouldn't even go as far as suing a publisher for a faulty product like someone would if they were promised a fully functioning application but got something buggy. To be fair, video games don't need much of your information to function properly. In most cases, they don't even need anything from you. Aside from an email address when you sign in to play on Ubisoft or Origin for EA games, or maybe a username, there's not much else they need to work properly. Regular apps need more personal information not only for authentication and authorization purposes, but also to customize the experience according to your usage statistics. At number 6 are the resources available for learning. Web development and other types of programming are quite vast and have accumulated a lot of articles, tutorials, and courses ever since software became a thing. For someone thinking of going down one of those paths, they have an embarrassment of riches when it comes to what they want to learn and who they want to teach them. If you're not sure which one to choose, I have a video you can check out on what to look for in a good course. Over on Udemy, there are hundreds of, say, JavaScript comprehensive and crash courses to help you get to where you want. However, if you search for game programming, the list isn't as big and there isn't as much to choose from. A game developer isn't as in demand as, say, web dev, but that's another point I'll discuss shortly. With game programming, your options are much more limited, especially if you're thinking of going the self-taught route. Currently, Unity and Unreal are free game engines you can download and tinker with for now, but they're only 2 of the few game engines out there anyone can use. Most of the time, developers create the game engine from scratch the final game runs on, which itself is a very complex and time-consuming process. Aside from different character models and environments, this is one of the main reasons different games look and feel different when you play them. As someone who's done quite a bit of research into game development and the indie games scene, I'm yet to see a course that teaches you how to make a game engine. Such a topic would probably be too large to cover in just a few hours. One option would be to go to a college to learn about it, but colleges that teach game development aren't that many. This is also dependent on where you're located in the world. Someone in India, Ecuador, or Egypt will have fewer options to learn about game development than someone in North America or Europe. Building off of number 6, number 5 with job opportunities. As I mentioned, regular programming has more job openings, with the industry expected to grow as the world goes online more and more each day, especially after what happened with the COVID pandemic. Gaming also increased during the pandemic, but the argument can be made the pandemic's the main reason for the spike. From what I've learned, gaming is a rather tough industry to break into. As a regular programmer, you can be assured that as long as people need to make money, you're likely to find an opening for a software developer job. It's safe to say every business in the 21st century needs an online presence to thrive. And with this need comes a demand for developers to make those websites and web apps. From startups to mid-sized companies to global names like Microsoft and Google, software developer jobs are here to stay. This too isn't restricted to a few countries or a section of the world. It's pretty much worldwide. Where there's the internet, there you will find developers also. The same can't be said for game programming jobs. As it is with other forms of entertainment, people don't need video games to live. This makes it much harder to convince people a video game is worth their time and money. To make matters worse, compared to other products, video games are popular with a much smaller demographic globally, not to mention the number who aren't able to afford the games or hardware to begin with. These are just a few factors that make it harder for studios to survive in a very competitive market, resulting in closures and loss of jobs in the games industry. For example, Google Stadia shut down, resulting in many jobs being lost. Blizzard laid off many of its employees too recently. If finding jobs is hard, then keeping them after can be just as troublesome in the games industry. As for the workplace culture, it's no secret that many studios implement something known as crunch, where teams working on games work longer hours to release the game by the deadline. Studios like Naughty Dog and CD Projekt Red have been accused of this in the past, so these are things to consider before trying to break into the games industry. Coming in at number 4 is the quote-unquote number of QAs. For those of you who don't know, QA simply means quality assurance, the checking of the final product to make sure it has no mistakes. I say QA in quotes because in game programming, you have way more people looking for exploits in the game to either help them advance faster or give them an advantage against other players. The whole experience is QA because as a form of entertainment, any little thing in a video game that breaks the fourth wall will be noticed, whether that's an NPC colliding awkwardly with objects or weird lip movements when characters talk. Just to be clear, looking for exploits is different from hacking. Hacking is trying to gain unauthorized access to data such as source code, whereas exploits are unintended mechanics that come about based on the code that's already there. In regular apps, there aren't many users looking for exploits, they just want what they came for. These are mostly laymen and women who know little about software and how it works. In contrast, gamers know quite a bit about the process of making games and are more likely to try different things to advance faster. Even if it's not intended, sometimes sheer curiosity can unveil exploits the game programmer may have not accounted for. As a game programmer, it's fair to say there will be things in your games that will surprise you more than once. The curiosity gamers have is second to none, and that's something you'll see firsthand after you make a game and get some feedback. The larger the feedback pool, the more things you'll discover don't work the way you intended. Number 3 is your potential to make a lot of money with simple programs. Simple here is a bit relative because what may be easy for one developer could be quite difficult for another, so for this instance, I'll be referring to the idea itself rather than the implementation. A regular program like a weather app would probably be more difficult to make money off of given the amount of competition out there, but with video games, it's wide open. There are so many games you can make, from click and point games to guessing games. Take a look at Candy Crush. This is a simple match 3 game that we've seen replicated many times over way before its release date in 2012. But look at just how successful it's been. The game eventually sold for $5.9 billion just 4 years later. Another example would be Untitled Goose Game, where you play as a goose honking at random people and disrupting their daily activities. Who would buy such a silly game, right? Well, after barely 3 months, the game had sold 1 million copies, meaning even if the game cost $1, it actually costs 20. That's at least $1 million in revenue. There are other examples too, like the recently released Fall Guys as well as Among Us. Can the same be said for regular programs though? Yes and no. Regular programs are designed to solve a problem, to make things easier for the end consumer. Often, the problem users have are complex and require complex solutions, which in turn require larger teams to fix. On the other hand, if the problem is a small one, then it won't take too much to fix it. For this reason, yes, a simple program could potentially make a lot of money if it fixes a small problem, possibly a hidden one the bigger companies haven't figured out yet that a lot of people have. No, because there's so much competition in the tech space, innovation is getting harder and harder to find. The problem also varies by geographical location. Different places have different needs, so a dilemma exists here. The simple problems are most prevalent in developing countries, but developing countries don't have that much money, so it would be harder to make the same amount as you would have had you solved a problem in a developed country. I'll leave this one to you to decide which one is more feasible. Our penultimate entry in the list is straightforwardness. In regular programming, you kind of already know beforehand what the application is meant to do and how it's going to achieve that. This is an oversimplification of the process, but compared to video games, the road is much clearer. For example, in regular programming, you know that once a user enters their details, some authentication is done, the user gets to see their stuff and do their business. It's a lot more straightforward. There's unexpected interaction with unexpected outcome, and whatever errors arise are approached with the aim of steering the application back to that desired destination. With game programming, there are way too many interactions to account for because that's how the game is meant to be. Granted, there are games with a linear storyline, but even those almost always include another element, whether that's collecting hidden items, destroying a certain object in each level, or performing a series of steps to unlock a certain piece of dialogue. The key ingredient in game programming that takes that expected blueprint and shreds it to a million pieces is creativity. Everything is literally made up, and because of this, the possibilities are virtually endless. In game programming, you also have to worry about other things like maintaining a steady frame rate, hardware limitations, optimizing your game for different platforms, and many other things regular programs don't need to worry too much about. A regular program has a finite beginning and a finite end. You open the app, call your Uber, the driver gets the notification, arrives, gets you where you want to go, you pay, and maybe leave a rating, and that's the end of your interaction with the app. Many games, especially the games as a service one, blur these lines so much the gamer doesn't know where to start or where to stop, because the aim is to keep them in this feedback loop where they're always playing. All things considered, this is what any developer wants with their application, high user retention. But in my opinion, this is harder with game programming. Let me know what you think in the comments below. Finally, at number 1 is bugs becoming features. This is something that has happened quite a bit throughout gaming's history, whether intentional or not. In regular programming, it's quite uncommon for a bug to become a feature. In fact, any bugs could have greater ramifications down the road if left unchecked. This all goes back to the risks involved I mentioned earlier. Once word gets out this company is using software filled with bugs and turning them into features, then it's only a matter of time before the lawsuits come streaming in. Such news in the gaming world, if anything, would be welcomed as a happy accident, as the late Bob Ross would put it. It adds to the experience as an extra piece of content, further reinforcing the gamer's love for the game in which the bug became a feature. I doubt there's a developer out there that likes having bugs in their code, but game programmers are one of the few I can say have this little bit of wiggle room when it comes to errors. It doesn't happen every day, but I'm sure when it does, the developer breathes an extra sigh of relief. Some examples of bugs that became features in games include wall jumping in Super Mario Bros. And the final appearance of creepers in Minecraft. That's all I had for you guys. Do you know of any other differences between regular programming and game programming? Let's talk more about this over on Twitter or on the Discord server. Thank you so much for watching, and as always, from me to you, deuces.